Why does Valgrind crash during C++ debugging? Have you ever wondered why Valgrind might crash while you are debugging your C++ programs? This can be frustrating, especially when you are trying to identify and fix bugs. Let's break down some reasons why this happens and how you can avoid it. Valgrind operates by running your program in a virtual environment. It monitors memory usage and detects errors like invalid memory access and leaks. However, the complex nature of C++ can create challenges for Valgrind. One reason Valgrind may crash is due to the use of just-in-time compilation or self-modifying code. These techniques can confuse Valgrind since it relies on a stable codebase to track memory operations. If your program uses these methods, Valgrind might not be able to analyze it correctly, leading to a crash. Another factor is the advanced features of C++. C++ supports templates, inline functions, and exceptions. If your code is compiled without debugging symbols or is heavily optimized, Valgrind may struggle to connect the runtime behavior to your source code. This can result in crashes or confusing error messages. Compiling your program without debugging symbols is another common issue. If you do not use the debugging flag, Valgrind cannot provide detailed error reports. This can make it seem like Valgrind has crashed when it is just unable to find the necessary information. Memory errors in the program itself can also cause Valgrind to crash. If your code has invalid reads or writes, it may crash while running under Valgrind. Although the crash originates from your program, it can appear as if Valgrind is at fault. Sometimes, bugs or limitations in Valgrind can cause crashes, especially with newer C++ standards. Keeping Valgrind updated to the latest stable version can help reduce this risk. When using Valgrind with the new debugger, misconfigurations can lead to crashes. If debugging symbols are missing or if Valgrind's instrumentation interferes, it may cause issues during execution. To prevent Valgrind from crashing, compile your program with debugging symbols enabled and disable optimizations. This will help Valgrind analyze your code more accurately. Using Valgrind's memcheck tool with specific options can provide detailed reports on memory errors. Make sure to update both Valgrind and the new debugger to their latest versions for better support. If your program uses just-in-time compilation or self-modifying code, consider disabling those features during debugging. Running Valgrind with verbose logging can also help capture more diagnostic information if it crashes unexpectedly. Combining Valgrind with the new debugger requires careful synchronization. Ensure that debugging symbols are present to avoid conflicts. By understanding these causes and applying these practices, you can improve your experience with debugging C++ programs using Valgrind. This will help you identify and fix programming bugs effectively without being hindered by crashes.